Okay, on assignment 4, we've got this one called Get Issue Detail. And I wanted to kind of run through some of the stuff for the code for that, for implementing it. And I'll actually go through and walk through the implementation in this. But first, I want to show you the data. I have a sample of calling that. And the way that I did the sample is first of all, I've got this query. And we'll run the query in here in a second, but I want to show you the sample first. Basically, it does a wget, and it takes the output, that's right there, the two outputs. The first one is the status output, the second one is the actual data. And you'll notice that if you're going to call this, you're going to have to change the IP address in here to your IP address. But then it does a get issue detail with an issue that's provided in the sample data. So if I put this up here, cat, and we put that into, I'll check that file in so that you actually have access to that file. But the output of that is this file that I'm going to show you. And this is the correct solution for how you want to return the data for get issue detail. And it looks like this. And it looks like we've pulled back a single issue with the body, the created, the IDs. And down here we've got the severity, the title, the other information with an issue. But it also has embedded in it the number of rows that are notes, which in this case is 2 for this particular issue. And then it has an array. You'll see the array starts right there and ends right there in the JSON data. And for each entry in the array, we have the associated note. If we look, we'll see that this issue ID right here is the same as the ID that we have up here. So these are the associated notes. They're done in order. In this particular case, the sequence is 1 and the sequence is 2. I would not expect you to get back those same sequence values, but they are ordered to get back those sequences. And here's all the details on the notes that are associated with this. And the way this is used in the front end is when you go to update a note or go to update an issue, it also lists the notes. And this is the details that are associated with an issue. Now, what makes this important is if I go into PSQL, and I actually run the query, this is what you get when you just do a select and join the tables. Now, I haven't included all the columns here, but you'll notice that what's happened is I've duplicated the data from the notes. Sample issue 2 there appears multiple times. And this is the result of doing a join on that data and returning it. Now, if you have a whole bunch of things that you're joining to, you end up with this big union of the set of all the information. And this is one way of getting back something with its details, but it's really an inefficient way of doing it because now we've got all of these union together copies of the parent table. Okay, so we've got a one-to-many relationship and we've created duplicate copies of the one side to match all the many side. And you see this in front ends with weird code to go out and remove the duplicates. Another way of doing this, and I'll tell you a story about that, very brief story, is where instead you pull out the parent code and then on the front end they go and one at a time get the rows for all the pieces of the many in the one-to-many relationship. That is the worst way of doing it. And there's also the one where you pull out the parent code and then you do a separate call again to the back end to get all of the related notes. Again, this means multiple times back and forth across your slowest piece, which is your communication from your front end to your back end. So what we would like to have is like what we saw up here in the data, where you've returned the relevant data in a single call to be able to manipulate the front end. And you've got the number of rows of notes that you have. You could get that by just having a length of the table, but you've also got the actual notes there as well. Now, The story that I would tell you about this is how important this is. I did some work for a European company a while back to do performance tuning. Their front end, they're painting a product, and in the process of painting a single product, they've got to get all the information about what the details of the product are, what the comments of the product are, all this stuff. And when you counted out the number of requests across their very carefully designed object relational mapping system, they had 143 requests to paint a single product. And of course, if you're doing 143 network interactions, your slowest piece, it's going to be really slow. So what did I do for them? I went in and I wrote a stored procedure in Postgres that they asked for a product, and what did it do? It packaged up all the stuff for the product and sent it back at once. And yeah, it made it faster for a bunch of reasons. They were requesting individual things one at a time, but it also made it faster just because we have fewer network requests going back and forth. And that met their performance goals. When I did contract work in Denver for performance tuning, a little bit over half of all the contract work that I did in a summer for 37 companies had to do with object relational mapping and this problem. So this is like the problem you see in object relational mappers. They want to say, we're going to create something object-oriented in the code. You're going to get a parent, and then for each thing in an array and a parent, we're going to go out and we're going to pull it out from the database one at a time and tack it on into an array. And sometimes you do this again for another layer down, and it becomes a really slow process. When a lot of times the database is really good at doing things together and saying, give me all of this. So what we want to do in the code is we want to do something to get the parent, and then we're going to do something else, another second select in the same query to be able to turn around and get all the children. We're going to stick it all together into one piece, serialize it into JSON, and then send it back to the client. So let's actually implement it that way and see how it goes. Okay, first of all, let's just comment out this default return. We may want it later. Let's go find something in here where we go and find dict equals, because I know that there are other places in the code where I pull back, like right here. We'll copy those 6 lines. Okay, and we'll put those in, but I really want, when I do this, I don't want a node ID, I want an issue ID, because that's what I'm going to need to return. Or that's what the parameter is coming in as an issue ID. So let's get those guys. Now that's the input that I actually don't think I need that anymore. That's the input. And once I have that, I can now get the issues. But rather than getting the issues back as a gob of JSON data as a string, I'd really like to get back the data structure, the raw data structure. So if I do issue data equals run select raw, and I pass it select star from iIssue, where, and I want to substitute in this issue ID equals, and I've done a typo right there. And it's a string in this case because we're passing it in as a parameter. It'll get converted to a UUID, and then I create the dictionary out here with the values in it. Issue ID, colon, which is the name, and issue ID is my variable if I'm looking at it correctly. And that wrapped on the screen because my screen isn't real wide there. Okay, so now I've got the issue. And what I really need out of that is the result of the select, which is the set of rows, the data structure, which if I go poking in there is going to be the result field. So issue result equals data result. Okay. Now, if I got a row back, this is what I want to do. Is if I have a row, if it actually found an issue, if that was a valid issue ID, so we're going to look at if issue data n rows is the number of rows returned, is equal to 1. Now, I know from, whoops, that is me putting in the wrong language syntax. I know from programming that that the number of rows returned is either 1 or 0, because issue ID is a unique key. So if I provide a value, it's either going to give me 1 or 0 rows. There's no choice there. And I still got my select wrong. Okay, there we go. Now, if I have 1, then there might be notes associated. Okay, so this is might have notes. Okay, and otherwise I know that since it is a unique key, that if it's some other value, I don't have any notes, which means that I want to set those two fields that are related to notes. Issue results sub 0 sub note. Equal to an empty list because there were no notes. And I want to take that and the number of rows that are notes. Is it rows notes? Okay, I've got to look at the data. It is over there on the other screen. Equal to how many do we have? If we don't have any, we have 0. And this is not the query that goes out and gets the notes yet, but we'll create the string with just JSON dumps. And there are some parameters for this that we have to have. And the first one is the data itself, the issue result. The second one is we want to sort the keys. It'll make us easier on us humans, but takes more time. It doesn't make any difference to the code on the front end if we sort it, but if we sort the keys, then when we actually get back results, we can read them and they're all in alphabetical order. The same thing for indentation. If we leave off the indentation, it'll come out as one big long string and it's hard to read. And we have this default equals default function that we're passing to it so that if it has dates and timestamps, it formats it correctly. So that's the serialization of the data. Now, after we get that done, there is some code here that we have to wrap around our return value. That's this information. Number of rows equals 1 and status equals success. Because the data goes in a field called data with an array of rows of data. So let's go and add that. So here's where we get to something like return. And because I'm returning this as JSON data, I'm going to do quote like this. And then I'm going to concatenate that to the body here. The reason I don't want to do a squiggle there is because that's going to interfere with me using format. So I'm going to do status. The backslash, or because I'm using a single quote and I've got to get a quote mark in there. Status success. And a comma, number of rows. This I need to substitute in a value for this, I think. Actually, no, this is a constant. It's 1 row because it's either 1 or 0. Actually, I do need to substitute in a value there. So we want to put in something like that for the value because it could be 0 rows. And then we want the actual data. And the data we want to substitute in because we got it up above in a variable. So that's .format, and now the number of rows, I'm going to put in NR. I don't actually have a variable for that yet, but I will here in a second. And issue data. No, I want SS because that's the string that I've already formatted it in. And then after that, we want to concatenate on that closing squiggle bracket. So that's what we want to return. Now, up here, we want to say that our number of rows equals 1, and our number of rows here equals 0. So we've got that variable set up for down below when we do the format. And I could pull that out of issue data number of rows, but we'll just create a variable for it like that. And now we've got to select the notes. Now, that's a second select that we're going to run. And let's see. Note data equals run select raw with select star from iNote, where issue ID, this is the foreign key that we're joining on, is equal to issue ID. I have put in a typo again for that. Didn't I do a typo last time where I put in a $sign and then had to like fix it? And issue ID. And we want this in sequence order, so we have to have an order by sequence. The default on an order by is ascending, which is what we want, so we can just put order by sequence. We don't have to put by order by sequence ascending. And then we want to substitute in the issue ID. Issue ID like so. Now when we get back the data, whether we get any data or not, we can just save it into this issue result. Okay, actually, these are the two things I want to save. Is the data, which would be the note data result, and the note data and rows. And I see I have another typo over here, an O note. Okay, so those are the two things that we want to save back. And once we have those things set up, I'm actually going to shuffle my comments here to a little bit better position. It'll be a little clearer and cleaner. But basically, that's what it takes to implement this. And instead of just returning a join, okay, which would give us bad performance and cause us work, or instead of making the front end do multiple requests to get things, we've taken an entire request. We've said, for this request, we understand what the front end needs. It's going to need an issue and all the related details that come with that issue. And I'm going to package it all up in one piece and send it all at once. Now, all we have to do is go and test this, but that's kind of the general idea of what it takes to do this. I might do some other things in terms of code cleanup, capitalize my selects and my select statements so they look a little more uniform with all the rest of the code. But basically, that's the piece of code that we need to be able to run this. Minus me doing some testing and verifying that it actually works here, and probably fix a defect or two or a typo or two. That's the piece of code. It's not a complicated thing, but it has buried in it a couple important concepts that will prevent all sorts of weird performance issues and deal with data at a reasonable level. Now, the other alternative to doing something like this is in Postgres, we can actually return data like this directly from the database with a stored procedure. And we could actually code this in and then just select the JSON data back from the stored procedure all in one select, which would actually be more efficient because, again, each time you do a run select, it's going from your application to the database and back. You would reduce network trips. But that is not generally your slow network. Usually your application server is either on the same machine or sitting right next to that machine on a high-speed network. Your slow connection is from the front end to the back end, and that's usually thousands of times slower than what your application server gets. So that's the one you want to optimize for and package things up in reasonable chunks for the front end. This is also where we're going to spend some time looking at how you do a RESTful interface. Okay, this is the kind of thing where REST falls down, and instead of tying everything to table size, row size chunks of data, you'd like to be able to get a lot of data, manipulate data, and get it in chunks, okay, that make sense to the front end. So as a person designing a useful interface for an API, this is the kind of thing where you have to work closely with your front-end people to make certain that as you're building this, you're building what they need to support that front end, or as you're building some piece of thing that's searching and somebody's going to use it in some application across an API, that you're actually building the pieces that will be useful without making lots of requests.